In today's lesson, we are going to be looking at the sine law. So this is the last little bit of the trigonometry that we're going to learn in this course. We've looked previously at right-angled trigonometry, so the sine and cosine and tan ratios, where we can find the angles or sides of a right-angled triangle. We've also looked at the sine wave, which is a periodic function, but now we're going to be looking at the sine law. And the sine law is similar to the ratios in that it helps us find angles or sides of triangles. However, it's different from those ratios because it works for non-right angled triangles. So if we have a non-right angled triangle, we use the sine law and the cosine law, which we'll learn later, to help us find sides and angles. So the sine law is a ratio or a comparison of ratios between the sine of an angle and its corresponding side. So the ratio of the angle and the side are equal to the ratio of every other angle and its corresponding side. So the big thing when we're dealing with the sine law is that we're looking for pairs. And by pairs, I mean an angle. So if this is angle B, we're looking for the pair of angle B and side B. And the ratio of those two is going to be equal to the ratio of angle A and side A, which will also be equal to the ratio of angle C and side C. And one thing we just want to keep in mind, the paired side is opposite of the angle. So the sides that the angle is paired with is always going to be opposite or across from the angle. Now we have two different formulas. Essentially, it's the same thing. Sometimes when we're solving for angles, we like to put the angles on top. Sometimes when we're solving for the side lengths, we put the angle or the sides on the top. Now it doesn't really matter which one you do because as we go through the steps, it's going to work out the same anyways. So the steps to working with the sine law, make sure you're dealing with a non-right triangle. We're going to write out the sine law using the given labels. We're going to plug in everything we know. We're going to get rid of the ratio we aren't using, right? So essentially what we're going to do, we're going to keep a complete ratio and the ratio that contains the side or angle you want. So essentially we're going to have a full pair and a half pair. The third ratio or the third pairing doesn't really matter. We're only going to really look for two, because we can't really have two equal signs when we go through and solve. And then finally, we're going to use cross multiplication to solve for our side or angle. So first, let's consider the following triangle. If we look at the ratios, so if we look at our triangle here, sine of 60, or sorry, sine of 30 divided by 10 gives us 0.05. If we do the sine of 60 divided by 17.3, that also gives us 0.05. So basically it's saying that the ratio of this side to this side is the same. And does this work for all triangles? In our case, yes. So yes, it does. Because that is how the sine law works, right? That's part of why we're setting up those ratios. Now you may come into some situations if you have like an obtuse triangle where the sine law may not work entirely. So these ratios may be slightly off or inverted. But for the purposes of what we're looking at, yes, this does work for all triangles, because again, that's how the ratio gets applied. So what we want to do next is we want to solve the following triangle. When we say solve the following triangle, we want to find all sides and angles. So It's not a right angle triangle. We only have one angle given. There's no indication that the other angles are going to be a right angle. So we need to find our missing sides and angles. I can't use any of the ratios, so I'm going to have to try to see my sine law. I see that I have a full pair here and half a pair here because I'm missing this angle. So I can use my sine law to find that angle. So in this case, I have sine c over little c equals sine a over little a. I'm not worrying about the third pair right now because in this case it doesn't really matter. I don't require any of that information to solve for the missing angle A. Once we figure out what ratios we're using, we're going to plug in our information. So sine of 75 divided by 15 equals sine A divided by 11. Once we do that, we cross multiply. We get 11 times sine 75 is equal to 15 sine A. To get the 15 by itself, we have to bring it back over and we end up dividing by 15. So I can divide this right now or do this calculation. I can do 11 times sine 75 divided by 15. I get 0.70835 equals sine A. And then the same with the ratios. Anytime we're trying to find an angle, we have to do the inverse. So sine negative 1, 0.70835, which will give us our angle. Let me just make some space here. In the end, we should get that A is equal to 45.1, or we can round to 45. So now we know that angle A is 45 degrees. So we still need to find another missing angle. We need to find B, and we need to find side length B. Angle B is easy to find now because I already know the two other angles. So I can do 180 minus 45 minus 75. Which gives me an angle of 60 degrees. And now I have enough information because I have a half pair now with side B. I can go through and find that missing side. So I can do sine B over little b equals, and now I have two full pairs to choose from, either A or C. I'm going to choose C only because I was previously given that information. I know for sure that angle C and side C are correct. If I did a calculation wrong, maybe angle A is incorrect. Now that would mean that angle B is also incorrect, but at least I'm trying to limit what is incorrect in my formula. So sine B or sine of 60 is equal to little b equals, and then we have sine of 75 divided by 15. The first step is to cross multiply. So we get 15 sine 60 equals b times sine 75. I want to move the sine 75 over. So 15 sine 60 divided by sine 75 is equal to b. And now this is just one calculation. So you don't have to do anything special. You don't have to do any inverses here when we're trying to solve for a side length. We should get 13.45 equals b, or little b or side b. So those are our two missing sides. We all previously found or missing angle, missing angle, missing side. So we have solved this triangle. We've found every piece of information that we need. One thing to keep in mind you do want to have your calculators in degree mode. So you should look on your calculator. It should be above the number line. You should see either DEG or just a D to indicate that you're in degree mode. If you're not, you might see an R, which means you're in radians, which is using a different unit for angles. We want to be in degrees because otherwise we will be getting different answers. So make sure your calculator is in degree mode. Next, we're just going to look at two word problems just to kind of get used to the idea of kind of visualizing a triangle. So a weather balloon is located between two tracking stations. It has an angle of elevation of 62 degrees from one tracking station and an angle of 47 from the second. The tracking stations are 3 kilometers apart. How far is the balloon from the first station? So let's draw our little weather balloon. Let's assume that maybe it looks like an actual balloon. We have 2 weather stations apart. .62 degrees is one angle, 47 degrees is the other. And we're told that the 2 stations are 3 kilometers apart. We want to find out how far is the balloon from the first station. So in this case, we need to have a full pair and half a pair. However, right now we don't have a full pair and a half a pair. I should be using this pair for sure. If that's the side I'm looking for, I need to be using that half pair. So where can a full pair come from? Well, we might be able to see that because I have 2 angles in my triangle already, I can use the idea that all angles in a triangle add up to 180. So I can do 180 minus 62 minus 47 equals that missing angle, or in this case, 71 degrees. So I now have an angle. So that means that I have a full pair and I have a half pair. So that will give me enough information to solve for that missing side. So sine of, we'll say just a over little a equals sine of b over little b. Again, it doesn't really matter what you label the sides, as long as you understand that one of those ratios will be full and the other one will only be half full, as well as that the capital letters represent the angles and the lowercase letters represent the side lengths. So we should get sine 71 equals sine 71 over 3 equals sine of 47 over unknown, or little b. Or you could say x, just keep it generic. We're going to cross multiply. So b times sine 71 equals 3 times sine 47. To get b by itself, I move the sine 71 over. And it becomes division. This is now just one calculation. If you're using your phone or an iPhone or a phone calculator, you may have to do it in multiple steps. I definitely recommend a scientific calculator when you're dealing with trig, because it is a little bit easier to work with. But when you go through and you solve, you should get 2.32 kilometers is that missing side length. So the balloon is 2.32 kilometers from the first station. B is now asking, how high is the balloon? So if we kind of redraw our diagram, we have station 1, station 2, it's 3 kilometers apart. We know it's 62 degrees, we have 47 degrees. We know this is 2.32. Here's our balloon. We want to know how high is this balloon. So we want to figure out this measurement here. So how can I find that measurement? Well, the balloon and the ground should theoretically make a right angle. So I actually have a right angle triangle here with an unknown height, a hypotenuse of 2.32, and an angle of 62. Now, we don't know what the bottom length is, but that's okay because we don't really need it because we have enough information here to solve for this missing side length. First things with the ratios, or though with the regular right angle trig, remember we want to label our sides. So our hypotenuse is across from the angle, or the right angle. Opposite is across from our given angle, and the adjacent is beside. So in this case, we're dealing with the opposite and the hypotenuse. So that is sine or SOHCAHTOA, right? So SOHCAHTOA tells us sine is opposite over hypotenuse. So sine theta equals opposite over hypotenuse. Sine of 62 is equal to x over 2.32. Out of the two scenarios, when solving for a side, this case we are going to bring the bottom up and multiply. So 2.32 times sine of 62 will equal our unknown side, or our height. 2.32 times sine of 62, and we get a height of 2.05 kilometers. So that is how high the balloon is. The next example, two ships, the Albacore and the Baffin, leave port at the same time in different directions. The Albacore traveled a distance of 40 miles, and now the distance between the two ships is 70 miles. A radar reading aboard the Baffin determines that the angle between the Albacore and the port is 24 degrees. So at what angle to each other did the ships leave the port? So if we have our port here, our two ships head out in different directions. The one, we'll call this the Albacore, this is the Baffin, this is our port. The Albacore traveled 40 miles. The distance between the two ships is now 70 miles. A reading aboard the Baffin determines that the angle between the Albacore and port is 24 degrees. So the angle between the Albacore and the port on the Baffin is 24 degrees. And we're trying to figure out what angle did they leave compared to each other. So we're trying to find this angle. So this one's relatively straightforward. We don't have to worry about finding any other missing sides because we have a full pair right here and we have our half pair right here. So we have enough information to find this missing angle. So we're going to set up our two ratios. So sine b over little b equals, we can say sine p over little p. Again, not that the letters really matter as long as we understand the angle goes with sine and the side length goes underneath, and they are paired up. So sine of 40, sine of 40, I just messed up. Sine of 24 over 40 is equal to sine of p over 70. So we're going to cross multiply. That's our first step. So 70 sine 24 equals 40 sine p. To get the 40 by itself, we have to move it back over. So 70 sine 24 divided by 40 is equal to sine p. So I can simplify that. So 70 times sine 24 divided by 40, I get 0.71179 is equal to sine p. However, that should look like an incorrect angle, right? That looks way too small to be an angle. And that's true because we still have one last step. Remember, anytime we're trying to solve for an angle, we have to use the inverse. So sine -1 of 0.71179 equals angle P. So we should get an angle of 45.4 degrees is equal to that angle. So that means that the two ships left each other at an angle with an angle of 45 degrees between them. B is asking now, determine how far did the baffin travel. So we can redraw our diagram just to help visualize. We had the albacore, we had the baffin. We knew it was 70 between them. The one traveled 40. We knew it was a 24-degree angle between the baffin, or on the baffin between the albacore and the port. We just determined that it was a 45-degree angle between the two ships when they left. So now we need to figure out how far did the baffin go, that third side. Again, it's not a right angle triangle. There's no indication that it is, so we do need to use where we can't use our ratios. So that means the only thing we know right now is our sine law. But unfortunately, in order to find this missing side, this needs to be my half pair, but I'm missing an angle. I have two full pairs that we can use, and I'm most likely going to use this full pair here, because again, that was given to me at the beginning. So in this case, I'm going to use this because I'm confident that it is correct. I know for sure that those two measurements are correct, so I'm confident that that part at least won't mess up my answer. I do still need to find this missing angle though, but luckily I do know the other two angles. So 180 minus 45 minus 24 is equal to 111. So now I know that missing angle there. Now I can go through and use my sine law. So sine of b over little b equals sine of a over little a. Sine of 24 over 40 equals sine of 111 over x. First step is to cross multiply. So in this case, x times sine 24 is equal to 40 times sine 111. Move the sine 24 over. Get x equals 40 sine 111 divided by sine 24. And this just becomes a calculation. Right? Take your time doing this. If you have to do it in steps, you can. So 40 times sine 111 divided by sine 24. X equals 91.81 kilometers or miles. So that is how far the boats or the baffin is from the port. So again, the main thing from this lesson is just understanding that when we're given a triangle that is not a right angle triangle, we have to use other formulas to calculate or to find the missing angles or sides. In this case, one of the examples is the sine law. And when using the sine law, we have to make sure that we have a full pair, so an angle and its complement, or it's an angle and its side, as well as a half pair, which it could be either the angle or side of the other missing piece. So if we're looking for a side, we should have the corresponding angle. If we are looking for an angle, we should have its corresponding side. Either way, we should have a full pair and a half pair. Plug it into your formula, cross multiply, and start to isolate or solve for our missing variable. So again, just make sure that you are date on that. You can review the trig lessons from previous units if needed to kind of get a refresher, because you may sometimes see right angled triangles pop up in some of the word questions, or just to get or refamiliarize yourself with trigonometry in general and using the sine and cosine ratios on your calculator.